Okay. So, hi, welcome. Thank you all for joining this webinar about the Arduino Opta PLC. My name is Clemens Valens, and I work for Elektor, and I will be assisting our guest presenter, Francesca Gentile from Italy. Francesca is the product manager at Arduino for the Opta product line, and so she knows everything about today's subject. Hello, Francesca. How are things today?
Hello, thanks, Clement, for the good presentation, and everything is fine. I'm really happy to be with you today and with all our audience.
Well, we are happy to have you. So today we will present the Arduino Opta family of programmable logic devices, also known as PLCs. There will be a lot of information, as always, but don't worry if you can't follow along with the presentation, because this webinar is being recorded, again, as always, and will be available afterwards on the Elektor TV channel for replay. At the end of this webinar, you can ask questions during the Q&A session. And there is also a giveaway. 5 Arduino Nano RP2040 Connect boards are available. To join the giveaway, please fill in the form. There's a form for it, and mention the code word Opta PLC. So Opta PLC. The link to the form will be pasted in the chat. So having that said, let's get started. Francesca, can you tell us why Arduino decided to invest in the PLC market?
Yes, of course. I have something to show you, just a few slides to support my speech and to tell you something more about this fantastic product that we have created. Just talking about the Arduino ecosystem, basically what we wanted to do was to bring our Arduino disruptive approach into the PSD world. So basically, our idea was, of course, to let's say, take a benefit of the Arduino pervasiveness that is basically counting plus than 3 million LinkedIn users that are basically saying about their Arduino skills over LinkedIn. And you see here the numbers are really, really huge, meaning that the Arduino skills are not just considered for the, as, let's say, a maker skill, but are also starting to be quite relevant into the business world. So what we wanted to do was effectively to bring something new into the PSD industry. And so basically we have designed a product that wanted to be really ready to step into the Industry 4.0, being a micro PSD with industrial IoT capabilities, which of course needed to start from a strong basis, being a product that is UL certified, CUL US certified, that is FCC certified, of course, CE certified. So it has an hardware basis that is fully industrial grade and certified, that has an hardware that can allow to effectively be powerful and flexible, meaning that we have equipped it with 4 electromechanical relays that are capable of switching 250 volts load for 10 amps. And we also wanted it to be flexible from the inputs standpoint. And we have given him 8 inputs that are programmable, meaning that they are capable of being used as digital, but also analog in the voltage range 0-10 volts. But of course, on top of this, we wanted to give something more. You see here that we have 3 variants of this product, because we wanted it to be, also to enable also other functionalities. First of all, in all of them, we have an Ethernet port that allows connectivity for what concerns TCP/IP protocols, but also, of course, field bus through Modbus TCP. We have an intermediate variant which enables also Modbus RTU through the RS485 terminal rack that we see here on the top. And we have a third variant that also enables radio communication, which means that through Wi-Fi and Bluetooth, we can, of course, leverage the connectivity to the network, but also enabling the collection of data from sensors in the field. All of these can be programmed through an USB-C through different methods. Here is quite let's say a simple dive in the product resources. But let's say moving forward to the connectivity, what we can see here is that effectively we wanted it to be really, really connected, meaning that all this product was meant to be suitable for a set of very, very different applications, from the very basics up to the most complex ones. And we have also given it a very powerful brain with an STM32H7 microcontroller, which is also able to implement real-time operations, to implement AI algorithms on the edge, for machine learning, for example. So we can do predictive maintenance, we can do really quick operations, and we have really a high computational capability. On top of this, for sure, we are pushing together with the, let's say, Arduino concepts that we all know, the simplicity of programming. And this is given by the fact that using the Arduino language, we are offering a real simple way of programming. So here I have just listed few of the commands that Arduino people are really used to apply in their programming. So for example, you can just actuate a switch through a digital write command. Very simple and straightforward. Said so, of course, all the libraries, function already existing can be reused thanks to the open source concept, which is something that is, of course, at the basis of all the Arduino Pro offering. So the concept is starting from what is provided by this community of let's say, gifted brains of people that are collaborating together and that are offering their code to be reused by other people. One other thing that we can do with Opta, as it is effectively a micro PLC, we also wanted to be inclusive with other languages. And for this scope, we have developed a software which is called PLC IDE, which allows basically to program it using the standard IC 61131-3 programming languages, so ladder logic, functional block diagram, structured text, in order also to enable this type of programming always on the same hardware. We will talk a bit about this maybe later. And of course, last but not least, this is a connected devices. We wanted also to leverage all the Arduino Cloud benefits, which means beautiful dashboards, possibility to have a remote control, remote actuation, visualization of what is happening on the field, and all of this in a very, very secure way, because Opta also integrates a secure element on board, which can guarantee a very simple and quick and secure onboarding procedure, but also the data integrity directly from the hardware standpoint. And this is basically our main offer. But sometimes what I hear from customers or people that see this product is that it can happen that the resources here may not be enough for some bigger projects. So in these cases, what happens is that some people in the past were using maybe Modbus to have remote IOs, but we will soon launch something new also to answer to these questions. And for this, basically, we will offer a new set of products that are called the Opta expansions, because as some of you might have noticed, and I can show you here, Opta has also an expansion port here. And this can be used to plug some other modules that are I/O modules, and that can enable new IOs to be used seamlessly with the main Opta module.
So you can make Optas as wide as you want?
Somehow, with we can make it for sure more capable of resources. So let me go through the next slides. So basically, here we will launch two new type of what we call the digital expansions. And for each expansion type, we will provide 16 new programmable inputs. So similar type of the ones that we have here in Opta, that can be used in voltage as digital or analog. And we will offer two options for the in the two variants that you see here on the screen for the outputs. So we will have either 8 electromechanical relays for 250 volts each for 6 amps, or we can have another variant which has solid state relays, so transistor relays basically, in DC, so 24 volts DC for 2 amps each. And it will be possible to snap on a controller module up to 5 new expansion modules. And this will effectively extend a lot the possibilities of the main module, because of course all of them will have the possibility to be used both with the Arduino IDE, both with the PLC IDE, and of course with the cloud, in a very intuitive and straightforward way, thanks to the library, the Arduino library that we have built, and thanks to the simple way of onboarding into the PLC IDE that we have built to make them really, let's say, self-detecting and straightforward to be used as basically native, almost native new IOs. And this is one type. We are also working on another type of expansion, that is one that we call the analog expansion. And this expansion will be basically offering different type of IOs, so the analog ones, because they will be able to be programmed in voltage, but also in current. We will have 6 inputs capable of working in voltage and current, but also with RTD. We will have 2 of them capable of working with 3 wires RTD, so to measure also temperature. We will have 2 outputs also capable of working in current or temperature. And we will also have, on top of this, 4 digital outputs as PWM. Again, all of these will be supported by both the Arduino IDE and PLC IDE. And this is more or less how these new IOs on the expansion will be distributed. Of course, all of them will be can be used as a mix and match, so anyone can create his own system based on what is his specific need for his project.
Okay. Now with all this, you have a lot of inputs and outputs and options and things. Arduino is known for its simplicity. Is Opta also simple? And if so, do you have documentation for it so that we can see how simple it is?
Oh, absolutely. Thanks a lot for the question. So let me share the screen here, because I would really love to show you where to start. So here we go. So basically, this docs.arduino.cc is our documentation page. Here you can see that we have divided the main blocks where to find our documentation into hardware, software, cloud, and programming. Looking specifically into the hardware block, you will be able to find listed all the products by type. And as today we're talking about Opta, we can find Opta here. So looking into this page, we can find, of course, the usual documentation, so the data sheet that can be clicked and can open directly a PDF with all the technical information, the pinout, the step files. But on top of this, there is something that is really effectively putting our customers in hands a kind of already pre-built material to get them started very, very quickly. So this user manual first is something that is created in a way that shows, of course, hardware software requirement, a bit of introduction, the functionalities of the product well explained, but gives already code snippets to really start putting hands on the product. And for all the functionalities that you see are listed here on the right, you can get into each functionality and follow up with basically very small projects to get into the product. So you can see how is the mapping of the inputs into the core, how to use them, with some very simple and commented code snippets that can be used to get trained or really hands-on on how to use the product. Except from that, or let's say on top of that, we also have the tutorials. The tutorials are some projects that are meant to be even a bit more realistic. So like, for example, we can take as an example the energy management project. And they are representing almost real use cases that are explaining how to use the product's functionalities in a somewhat similar to reality user environment or user project. And also here we have all the requirements so that a customer can basically reproduce or all of this setup, as well as all the parts well explained piece by piece to show up the functionalities. And also for sure all the complete sketch to be downloaded and tried by the user. This is more or less the way that we provide our documentation, but it's not only for Arduino, because as I said before, we also have a PLC IDE, which is our software that can be downloaded into our download page, which is this one. On this part, clicking on this link, it is possible to download the software. And here we can find all the documentation. So, for example, we can start by the setup and device activation. And also here we can see a very detailed step-by-step procedure to activate our product and to move forward with the first steps on the configuration. as well as, of course, more, let's say, detailed project. Like, for example, here we have a project even with a video tutorial to explain how to put in contact through Modbus TCP two of our products, Opta and Portenta machine control. And this is how, more or less, we provide our documentation with all our products, not only with Opta, let's say, but this is the way we offer our documents. Of course, we are also continuously updating them. So we really encourage you to get to our doc site because it's continuously evolving with new content.
Okay, that's a lot of documentation. You also mentioned the PLC IDE. I think a lot of our viewers are used to the Arduino IDE, but they may not know the PLC IDE. Can you, IDE, yes, IDE, that's the word. Mm-hmm. Can you please give a demo of it?
Yes, why not?
How it works, or what it looks like?
Yes, absolutely. So let me show you up this one. Okay, good. So basically here is, let me check you see it. Okay, great. Okay, so here basically I have an Opta already connected, which is the one that I have here. So you can see below that it is saying that it is already connected. But when you start with the Opta, everything is, of course, detailed into the former site that I was showing. You will get into, at the first program, you will get into here. It says connect the target. You will have just to go for a manual download by checking this automatic bootloader, and you will have to go through some few steps to enable it. Then this interface is basically configurable with every dockable window. So all of this is basically my setup, but you can just move all the windows. You can see you can dock them somewhere else. You can overlap them with something else, and that's it. You can. It is really fully configurable. Except from the environment easiness of use and configurability, the main parts of the PLC IDE that are really fundamental are these two. So the resources tab and the project tab. Starting from the project tab, here I have created a small program just to show you up something really working in reality. But here, this is the place where you can add new programs, or POUs are generally called here, and which are basically the programs that can be created in all of the 5 programming languages and assigned to a task. Of course, the PLC programming is always linked to the cyclical task execution. It can be we have 2 tasks that can be selected. The fast, that of course has higher priority, and that runs at 10 milliseconds, and the slow that runs at 100. Then we also have a background task that is, of course, the least priority task. And let's say we also have a possibility to configure the set period of the cyclical fast task to make it let's say bigger than 10 milliseconds. When a program is created, it can be effectively associated into a task, and there is a set of there is a possibility, of course, to use the variables with a very low code approach. So just by typing few words regarding the name of the variables, and eventually click on some drop-down menus, it is very, very easy to configure them. There are some really advanced tools also for debug here. So let's connect the target, and let's see, for example, the oscilloscope. Here I have tracked, I have tracked a few variables running. You see fast, main, count, fast main and lock one. I have just selected the ones in the main task, just to show how the oscilloscope works. This is a really nice debugging tool where we can see, for example, the samples one by one. We can stop it just to take measures. We can start it again. We can, let's say, put them into different levels. It is already quite an advanced tool. We also have the watch window that also allows to see the value of the variables growing. And we have even this function, which is called the live debug mode, which adds next to the variable the value in real time. So it's already quite an advanced tool also in terms of debugging. What else? Going back here, the resources tab has, this is the part that is really tailored for the product. Because we have basically decided, now I'm stopping here just because I don't want you to get crazy with this variable changing, but this part you see that it's meant for Opta. What does it mean? Meant for Opta means that the local I/O mapping is already pre-mapped for the list of I/Os of Opta. So here we see the 8 programmable inputs that we can select if to use as digital or analog, on which we can set up the resolution, because these are basically pure characteristics of Opta. And just by typing the name of the variable, we can configure it. Same as for the relay outputs, same for the 4 LEDs, because they are configurable. Sorry, +1, because the RGB of the Opta here is also configurable. And same for the button. We also have more advanced functionalities, which are, of course, related to Modbus, both master and slave, that can be achieved by publishing the public objects or by configuring in a very easy and straightforward way with this catalog that already gives the functions by type of function, like write single register or multiple register, etc. And that really helps a lot to do very low coding for the Modbus configuration. On top of this, we also have a part related to the sketch editor that can be used to add, thanks to the shared variables, also a part of the sketch. It has by default into the program this section that reminds how to use it by exchanging the variables between PLC and the sketch, basically, and also allows to exchange information between the sketch and basically the PLC runtime.
Okay, well, that was a very detailed explanation. But now, I think you also prepared a demo, didn't you? Maybe you can show it. Of course, it's very dangerous to do a live demo in a webinar, but we will give it a try anyway.
Yes,
what did you prepare?
Yes, of course, of course. Well, what I wanted to show you is something else related to the PLC ID. Because basically, as I said before, I promised that I'm just opening the right. Okay, here it is, the right program, because I wanted to show you something effectively working that I was not doing before. So let me see. Tell me just if you see something working here, and in parallel, I will share again the screen.
We want this screen full screen. Can we get this screen full screen? The PLC remove me? Yes, that's it.
Okay.
Okay.
So what?
Blinking.
Okay. So do you see it?
Yeah.
Okay. So what you see here is an Opta controller together with a couple of expansions. Maybe you might also hear the click, because here I have connected both an electromechanical and a solid state expansion. And these are the two ones on which you see this demo effect on the LEDs. Sorry, this and this. Sorry, but it's mirrored in the screen, so I was pointing to the wrong one. So basically, let me show you up. Maybe if you can just show the other screen. Yes, thanks a lot. Because basically, here is the program that I have created, and now I will just stop because it's just clicking. And this is the program that I have created also for the expansions, because as I was telling you before, we are about to launch the expansions, and we have prepared also the possibility to use the expansions in a very straightforward way with a self-scan option and the possibility to apply directly the hardware configuration that is prepared by the user, by the programmer, in a way that this configuration tree is already self-detected with the programmable inputs already preset in this way, very easy to use and straightforward, so that they can be really used into the programs. So what I have done here into the tasks is just programming something here in the slow. I have put it in the slow, but I could have put it somewhere else. So I have just used the relay expansion output as an input of a timer to turn on and then off the relay at a certain for a certain timer, doing it differently for different inputs and outputs, just to generate this, let's say, this game of LEDs and relays to get switched on and off. This was just to show you how simple is the onboarding also of the expansions models together with the Opta. Same way as I showed you before, but also with the new expansion tree with scan and apply detect config. We see them in the catalog name, in the catalog for the expansions, and that's it. Easy and simple.
Okay, wonderful. But can you do this also with the Arduino IDE?
Yes, sure. Okay, so let me just stop this and let me quickly open the Arduino IDE. And show you up. Regarding the easiness with Arduino IDE, also with the expansions. Okay, so this is the usual Arduino IDE that you all know. And in order to simply and straightforward use the expansions, we have created a library that is called Opta Blueprint. So here, of course, I have it installed. Okay, I can update it. There is already an update. This is already available. So we have already published it. So as soon as the expansions will be ready to be purchased, it can be simply downloaded. The interesting thing here is that we have prepared, of course, a set of sketches already predefined in order to make our customers' life very, very simple. So we can, for example, directly use sketches to get the digital inputs. And this is also another way Arduino uses to provide information and to provide knowledge by giving some pre-written sketches into the library. So here you see that we have some part of setup. a part of functions that can be used, and all of these is basically explained through comments, so that a user can not only just use the code as it is written, but change it on purpose of his needs, basically. So reuse it and change it, and of course also merge it using all the possibilities that are already given. Like we have selected, for example, get digital, we have a get analog, we have a set digital. So almost all the options that are available for the expansions are also described into the library sketches, and so can be reused by and mixed by a user to have their life simplified.
Okay, yeah, very good. Very Arduino. More Arduino is the Arduino cloud that you want us to use. So can you show us how we use this with the cloud?
Absolutely. Just give me a second. Okay. Arduino cloud. Okay. Let me show you. Let me start from this. This is something that can be created into Arduino Cloud, and I have also a demo to show you here again. So I am now sharing a dashboard that is something that can be effectively created in order to have remote control, remote visualization of the data that are arriving to the Opta, like telemetry data, for example, or we can do actuation, for example. Here I have created a very simple proof of concept, or let's say dashboard, just to show you up how much it is really simple and to drive you through the steps to do this. And this is just the result to show you up how it works. I have, for example, created here a simple, super simple sketch that is acting with some buttons to enable or disable the relays of my Opta on one side. So I don't know if you are able also to see the Opta itself. We have here the relays and the LEDs of the Opta. And here, this button is basically enable everything. This button is disabling only the relays of the expansion. This is disabling everything. So we can, of course, this is an idea to show up that we can manage, thanks to the Arduino Cloud, many things remotely. Here I have decided to do actuation, but of course we can display telemetry data, we can show statistics. So in order to show you up something, this is basically the environment where we can not only, of course, create dashboards, which are basically the final point after the creation of the sketch, but we start creating our thing here, and it's really easy. We just create some cloud variables that, in my case, I have associated to these buttons that you were seeing here. By this way, it's really easy. We give them a name. We say, for example, I don't know, we can put LED1. We select the type, like in my case, I have selected the Boolean type. And in my case, I have selected read and write because I needed both to read and write the variable. And I have given as an update policy the onChange. Adding the variable here, I have basically add something already added into the sketch. Should be on the bottom. You see it here. So the cloud itself is taking care about updating the code and putting some code snippets, some parts, in order to do part already of the job. This is more or less how I have created my sketch, starting from an already created set of void variable something snippet, and inserting in it, we can see one here, for example, and setting, let's say, the business logic of the system inside. So here I have put something, an if mechanism, of course, to say that if I had a cloud button enabled, I needed to make a digital write of the relay correspondent to that button, virtual button on the cloud, and let's say vice versa, if it was disabled, to put it low. This is very, very simple and straightforward, but just to show you up how it works and how simple it is to get this created. Also, in the beginning, the initialization is done with whatever is needed to make it work. Like, for example, you see here it starts saying that the sketch is generated by the Arduino cloud. The following variables are automatically generated and updated when changes are made to the thing, which is what we have created. And you see, for example, my new variable is Opta LED 1, which is here. It's a new one that we have created together, you and me now. And I have had just to add some pieces of code that I have, of course, captured from the information that I had, both from the library, the Arduino library that is exposing already the sketch examples, and of course the Arduino documentation that we will publish for the expansions very soon, as we launch them. And that's it. Really, really simple and straightforward as for the Arduino general paradigm.
Okay, well, thank you very much. I think you can talk for hours on the Opta family, about the Opta family, but we don't have that much time. I think we have about 15 minutes left, so I think we have to start to end the presentation now and maybe slowly move over to the Q&A session. Before we do that, please let me repeat that we have a giveaway, and the code word for that is Opta PLC, and that are 2 words. And the link to participate in the giveaway is in the chat. Let's now move over to the Q&A session and see if I can get them on screen.
Maybe I can start taking some, if you like.
Yeah, here is a question. Is there a way to link multiple Opta modules together so that I don't need to wire each of them using their own network cable?
Multiple Optas together. So, I mean, we have several ways of connecting Optas, but it depends on what you need to do. For the multiplication of the IOs, we are releasing the Opta expansions, which will be suitable to acquire many more data from sensors or to actuate many more devices. So this is for sure the easiest and preferable choice, because they can be used thanks to this expansion port. And so they will be snapped on, as I was showing here in the demos. So they will be basically packed together all through the DIN-Rail guide. And this is the easiest way to get many more IOs. And also from the library point of view, it will be really straightforward. Another case is if you have something remote, which is something that could happen maybe because you have really something very specific to be used in the field, like a remote field bus. And then in this case, you have two options, the Modbus RTU or Modbus TCP. And for this, you can benefit from the resources of the Opta, selecting the proper variant of the Opta controller. I hope I have answered
the question. Yes, maybe not, maybe you did. If you didn't, then we will ask again.
Of course.
The next question. Of course, we can't say it right now, I think, but yes, will this be as durable as other non-PLCs in the markets?
This product is an industrial grade product, so it is absolutely reliable. It is UL certified on top of the CE certification and so on. Let me just make a note on the professional Arduino line. All the Arduino professional products are conceived with this concept in mind. They are meant for professional use. So they have really a different conception in design, in the choice of the components to be effectively durable and suitable for the industrial market.
Yes, that reminds me, what is the difference between the Portenta and the Opta PLCs?
The Portenta series, I don't know if the person had in mind the Portenta machine control, maybe yes. The Portenta line is a series of products that are system of modules. So they are just, they are boards that can be used mainly to be integrated into other systems. And most of the time they require a carrier. I assume that the request is more related to the Portenta machine control. The main difference between the Portenta machine control and the Opta is that basically Opta is a compact micro PLC that has a totally closed box and is basically modular. So it can be its number of inputs can be multiplied by snapping on different modules. From now on, let's say, as soon as we will launch the expansions, but it will be very soon. While Portenta machine control is another type of hardware, also having PLC capabilities. It does not have electromechanical relays. It does not have this type of actuation. They can be, of course, added outside of the PLC ID, but it is a finished hardware. So it does not have expansion modules. It is not meant for that use. So in case the user needs to expand it in some ways, they will need to follow the approach of the TCP, the same that we were talking about before for remote field bus.
Okay. Back to the Q&A. Is there any PLC IDE under Linux? And if not, will there be?
What I have, the PLC IDE, thanks for the question, is supported through Windows, but many people that I know are anyway running it using a virtual machine through Linux, and it is pretty working fine.
Okay. Another one about PLC IDE. Sorry. I'm seeing now it's one file. Is everything inside?
Wonderful. I mean, our attendees are incredible and wonderful. So today we have launched effectively a new installer, which is supporting the new expansions, and it's also wrapping up in one single installer the two former files. So before we had an installation that was a little bit more, let's say, tricky, we can say. And in order to have the full installation, we needed to run at first an installer for the tools and next the installer for the software. Now we have created one single installer for the easiness of our customers. So it's just one click and the user needs just to follow up by click, 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 and it's done.
Okay,
Thanks a lot.
Good. And then more software. Is it possible in the future to use CodeSys with the Opta PLC?
Okay, thanks for the question. For the moment, we do not have run any test on CodeSys yet, because generally speaking, the languages are standard, and the interface itself is quite. It is quite common also, considering what is already in the field. CodeSys is of course a very good programming environment. Let's say that for our Opta, we are basically offering free of charge the programming environment, because Opta is pre-licensed. This is something also that I didn't say before, but when Opta comes to the customers, they do not have to pay any licensing fee for the full lifetime of Opta. And so basically through our PLC ID, we can also, let's say, follow the same paradigm of the open source, the openness, and being free also with the tools to program that generally is provided by Arduino. So this is also the reason why we have decided for our choice. But as I showed you, the ID itself is plenty of functionalities. So, generally speaking, is really well perceived anyway from programmers.
Okay. We have a question about debugging. Can you force an input or output for testing and debug?
I'm not sure I am catching the question you mean. Yes, I think that I'm catching the question. Yes, I think for example, if you go into the ladder logic variables and you use the tool that I was showing before, maybe I can show you again. Just 1 second. Now I need to open the other file. Oops, sorry. It should be this one. No, sorry. This one is the one that I was showing you before. For example, here, using this, I need to connect it. Okay, so when I connect it here, and I use the live debug, I can force the value. You see, it is already forced in this case. In fact, let me enlarge this. Let's see. Let me enlarge this a bit so that you can see the output. If you see this, it is colored.
Maybe, sorry, maybe you are in another window because we don't see anything.
You don't see the PLC ID?
Yes, we see the ID, but we don't see anything change, or
you don't see any. Okay. Let me stop and share again. Probably it was frozen. Thanks for advising. Okay, let me see what you see. Okay.
Yes, now we
this
see
is the right one. What I was saying is that this is a variable that has been forced because I have set it to 2. If I put it to false and I make set, you see that everything is, let's say the output is basically changing. So you can make debug by forcing effectively the values as I'm doing right now. Sorry. False.
Okay, well, I think you've made your point.
Yes, okay. And by the way, something that I take the chance to show here in the index, there is a very detailed user manual on which you can check out everything that is not specifically related to the hardware itself. So all the generic information related to the programming and functionalities of the software are contained into this manual, which is an online manual that can be retrieved from the help function of the IDE.
Okay. Here we have a question that I saw pop up when you talked about the cloud. So I suppose this relates to the cloud, creating variables in the cloud. How is the conversion done? For example, we have variables of various types, but my sensor can provide 2 or even 3 decimal places.
Of various types, but my sensor can provide 2 or even 3 decimal places. Frankly, it's a bit. I should dig a bit more into the question. So, Christian, sorry, but I will take this offline, and maybe I will with pleasure. I will answer to you with a more precise answer in a second moment, to be sure that I will tell you something something relevant.
Okay.
Let me see if I can take something.
So this is a more economical question. How is the Arduino market doing in the industrial products range?
We have had a lot of, let's say, a lot of enthusiasm around Opta, especially because it is something really easy and quick to be put in place with a lot of functionalities also, let's say, packed in a very small form factor. So just to give you an example, with the same form factor, we can have the connectivity through Modbus, which is something that generally in the same segment is provided by an extra part through an expansion. So let's say it is something that has been really well, it has been really well adopted. What I am sure of is that something that was a lot expected were the expansion modules, because of course the Opta itself can have kind of limited resources itself for bigger projects. So now that we will be out with the expansions as well, I think that it will be even more.
Okay. Another question here about energy consumption.
Well, this is not meant to be a low power device, of course, because it is a micro PLC that is meant to be powered up. We can maybe, if you have specific needs, we can make some evaluation. Of course, it is also related a lot with the sketch that it is running on top of it and everything that it needs to be done. So in case there is something that on which we need to dig more for a project, we have, in terms of Pro, we have a support team that is taking care of, let's say, big project, big customers to whom, of course, some support is needed and dedicated. And for sure, we can take this question offline and try to dig on the real specific need, because of course it can vary a lot based on the request to the PLC itself.
Okay, yeah, we're running out of time. We still have a few questions. I will do this one, which will interest a lot of people, I think. Will the use of the web interface be free?
I assume he's meaning the cloud. We have, let's say, we have several possibilities with cloud. We also have a Cloud Pro for our professional users that is, as of course, some plans that are specific. Everything can be seen on our pages. But we also have a free of charge plan that is a basic maker plan that can be used to test and to try some of the functionalities.
Okay. Another quick question. Is Opta supported by Platform IO?
Well, I mean, not officially. I mean, we did not get any specific internal tests, so I cannot tell anything specific about that. I have heard, I have seen something about people testing it, but there is no official support.
Okay. Technical question. The typical latency between an input change event and Opta code detecting it.
I don't remember by heart. We can. I will check and I can take it offline. Frankly speaking, I don't remember it by heart. Sorry.
Okay. Another one. Interrupt service routines. Mm-hmm. Will they work in the Arduino IDE as well in the PLC IDE?
Arduino IDE, for sure. I don't know if this is something that generally happens in the PLC IDE for how it is effectively structured as a cyclical programming. So I wouldn't, frankly, see it in this type of programming. We also have a sketch part, so theoretically it is doable to do that, but the sketch part is lower priority than all the other cyclical tasks. So,
okay, then we have a last question. Is there any offline software in which I can design a GUI for a user to control and monitor the data using Opta?
Offline software. Something like a web-based interface through Ethernet, I assume. Not as far as I know, but I might know it. So I can try to dig for it, and I can try to answer separately with some suggestions. Of course, might be not official ones. I mean, it's something that can be surely useful for people having this type of questions is to try to search in our forum, because very often, as in fact a community, there are some other people that have experimented things that we are not maybe doing in the professional world, but that can maybe suggest other alternatives that can also support different use cases that we didn't yet consider or we didn't consider at all.
Okay, well, thank you very much. I think we have to stop now. We have been more than 1 hour. Yes, thank you very much. Very interesting. As I said at the beginning, this webinar is available in a few days on the Elektor TV channel, so you can watch it again. And if you missed something, then you can watch it slowly and over again. Again, we have the giveaway with the code word Opta PLC. You have to fill the form in fill in the form, and we use this code word to make a chance of winning a giveaway board. Well, thank you, Francesca. Thank you for doing this webinar with me, and thank you all for attending. And we hope to see you again for the next Elektor webinar. Goodbye.
Thanks to you. Have a good day. Bye.